Welcome to 1.7 Solving Absolute Value Equations and Inequalities. Hi guys. I use math every day. Today, our objective is to solve absolute value equations and inequalities.
Recall that absolute value of a number x is written as, and these two bars mean the absolute value of, is, so it's the distance from 0. All right, so the absolute value, written like this, is the distance from 0. So make sure that you wrote down at least absolute value. Make sure you have the symbol in your notes and the definition, the distance from 0. So let's consider the equation, the absolute value of x equals 3. So what this means is that x can equal 3 or x can equal -3, because both -3 and +3 are 3 units, 1, 2, 3, 3 units, 1, 2, 3, from 0. So -3 is 3 units from 0, and +3 is 3 units from 0. So that's why equals, absolute value of x equals 3 can be x equals 3 or x equals -3. Now let's consider x is less than 3. So x is less than 3 means that x is greater than 3 and x is less than 3. So the absolute value of x is less than 3 is the distance that 3 is from 0, as well as all the numbers that are smaller than 3. So we have the part that's on the left side of 0, and we have the part that's on the right side of 0. So again, when we say, another way to write this is x is less than 3 and x is greater than -3. So that might be a little bit easier to understand than how the book wrote it up here. So what we're saying is that x is 3 units from 0, so it got an open because it doesn't have a line underneath it, but x could also be 2 units from 0 because that's smaller than 3, or 1 unit from 0, or somewhere in between 0 and -1. And then also, because x can be less than 3, we can be 3 units from 0. Again, it's an open circle because it cannot be exactly 3 units from 0 because this does not have the equality line, so it can be almost a 3, but it could also be 2 units from 0 because 2 is less than 3. It could be 1 unit from 0 because 1 is less than 3. So it's actually all the values between -3 and +3, and that's why it graphs like this. All right, so then we also have the absolute value of x is greater than 3. So the absolute value of x is greater than 3 means that x is greater than 3 or x is less than -3. So if we look at 3 units from 0, so 3 is 3 units from 0, but we want all the numbers that are bigger than 3. So that's why we highlight or draw an arrow to 4, 5, 6, 7, all the way to infinity. Also on the other side, -3 is 3 units from 0, but we want all the numbers that are past that. And so that's why we highlight or draw the arrow that represents all of these numbers. These numbers in between are not 3 units from 0, so they don't qualify, right? They're not less than 3 units from 0. Sorry, they're not more than 3 units from 0. So we have to be at least 3 units from 0 plus some in order to be a part of this inequality.
Please write this down. This is very important. Greater means or. Less than means and. To summarize, these are the 3 ways in which we can write absolute value. Equal signs make or. Less than is an and. Greater than is an or.
All right, so let's go ahead and look at this equation. We're going to solve the equation, the absolute value of -3 plus k, and then absolute value equals 10. So first, please make sure that you write this down. This is our first example. All right, once you have it written down, we need to decide if this is an equal to, a greater than, or a less than. So clearly this is an equal to. Hopefully you understand that we're talking about this. This sign right here is equal to, And because it's an equal to, that means that this is or. So we're going to write it without the absolute values. So notice I did not write down the absolute values. So I copied it exactly like it is, except for the absolute values. Then I write or, and then I write the part inside the absolute value again without the absolute value, except for this time I write a negative 10. So we can look at where it is on the right side of the graph and the left side of the graph. So now we're going to go ahead and solve these two equations. So we're going to plus 3 to both sides. We're going to get k equals 13, bring the or down, and then over here we're going to plus 3 to both sides, and k is going to be negative 7. So we don't have to graph because it just said solve, and both of these solutions with the word or in between them is our whole answer. All right, now let's look at this one. This is example number 2. Right, go ahead and write down the absolute value of 6x, and then in the absolute value, minus 8 equals 22. So again, the first thing we're going to look at is whether or not this is an equal to, a greater than, or less than. So we look at the sign and we notice that it's equal to, which means that this is going to be an or. So step 1 of these is that we have to get the absolute value by itself. So write down, get absolute value by itself. In order to get it by itself, we need to add 8 to both sides. So I'm going to add 8 to both sides of the equation, which is going to give us the absolute value of 6x. Notice I'm still writing the absolute value, equals 22 plus 8, which is 30. Once you have the absolute value by itself, we're going to separate into the compound inequality. So now we're going to separate into compound, so that means the and or the or thing, inequality. So we're going to do just like we did on the previous slide. Okay, so we're going to have 6x. Now, once I write the compound inequality, I no longer write the absolute value sign. So 6x equals 30. Because it's equal to, we do or, and then we do 6x equals negative 30, because we got to look at the right side and the left side. So we solve both of these equations. I'm going to divide by 6, divide by 6. And that's actually what step 3 is, to solve the equations. So x is equal to 5, or x is equal to negative 5. Both of those solutions work. And you can plug them in one at a time up here. So if I plug in positive 5, 30 minus 8 is 22. And then if I do negative 5, 6 times negative 5 is negative 30. Negative 30 is 30 units from 0, so that's positive 30, minus 8, which is 22. So both of these solutions work. So we are winners.
Here are the steps again, in case you would like to stop the video and write them down. You are awesome.
All right, now we're going to look at solving this inequality. So this is not an equation like the last one was, and we're going to solve the inequality, and then we're going to graph the solution. So please make sure that you write down the absolute value of negative 4q plus 2 in the absolute value greater than or equal to 10. So we need to look at this sign and determine if this is equal to, greater, or less than. So because this is greater, and greater makes that R sound, this is going to be an OR. So whenever we do OR statements, first thing, make sure that the absolute value is by itself. So you see that there's nothing outside the absolute value until you get to the inequality. So once you get to the inequality sign, then that moves over to the right side of the equation. So there's nothing in front, and there's nothing after the absolute value on the left side of the equation. So we're ready to go ahead and separate into a compound inequality. So I'm going to write negative 4q plus 2 greater than or equal to 10. So I copied exactly what I had up here without the absolute value. Then you write the word or. You copy what was in the absolute value again. So notice that all of these first parts match. I didn't change anything. And then you flip this guy over. So here's the first time I changed something. So it was a greater than, now it's a less than. and then this becomes negative. So look at this. Notice that this matches, this matches, and in the first part, these guys are the same. This one over here is opposite. This is the same. This one over here is negative. So then we just solve both equations. So I'm going to minus 2 on both sides of this equation. Negative 4q is greater than or equal to 8. Divide both sides by a negative 4. Recall that whenever you divide by a negative, you flip over the inequality. So we have q is less than or equal to negative 2, or, bring that or down, and now we solve this equation. So we minus 2 from both sides, and we have negative 4q is less than or equal to negative 14, right? When the signs are the same, oops, sorry, negative 12. When the signs are the same, you add and keep the sign, and then we divide both sides by negative 4. So again, whenever you divide by a negative, you have to flip over the inequality. So notice that that flipped over, and then work out the problem. So negative divided by negative is positive. So because it said to graph, I need to go one more step. So negative 3, negative 2, negative 1, 0, 1, 2, 3. So notice I just went one past on the left side and one past on the right side. So here, this has the line. So at negative 2, it's going to have a solid point. At positive 3, it's going to have a solid point. I need one more. All right. So does that make sense? Hopefully. All right. Now, because it's an or, it should go out, right? Ors go out just like oars of a boat. So Q is less than negative 2. So all the numbers that are less than negative 2 are to the left. Q is greater than 3. So all the numbers that are greater than 3 are to the right. And that looks right. Good job, us. All right, so let's look at number 4. Solve the compound inequality, then graph the solution set. So make sure you write this down. Negative 1/2 times the absolute value of p minus 2 absolute value is greater than or equal to 3. All right, let's write this down in big, giant, bold letters. Never, ever, 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 never distribute into absolute value. You cannot do that, right? You can't distribute. That is illegal. So write this down, bolden it, highlight it, do something so that you don't forget that. So now, our first step is to get the absolute value by itself, right? So we can see that this guy here, this negative 1/2, is in front of the absolute value. How is this negative 1/2 connected? He's connected by times. So the opposite of times is divide. Remember that when you divide by a fraction, you actually are multiplying by the reciprocal. So we're going to multiply both sides by negative 2 over 1. Negative 2 over 1, right? So a negative times a negative is positive, and then these guys cancel each other out. So we just have positive 1. So we're just going to write absolute value of p minus 2. Now, because we multiplied by a negative, we have to flip over the inequality. So all those rules always apply anytime you have an inequality. And 3 times a negative 2 is negative 6. All right, so if we look at this, what are all the values of absolute all the absolute value of p minus 2? So all the values that could work that are less than or equal to negative 6. So think of the numbers that are less than negative 6. That would be like negative 7, negative 8, negative 9. So none of these values will actually ever work. So this is an example of where you're going to have no solution. That's going to happen every once in a while, very rarely. And the reason we knew is if this is an equal sign, or if this is a less than sign, when this is negative, then it's no solution. If this was greater than, it would not have been no solution, because you can work out greater than a negative because those are where the positives are. All right, so just to review, whenever it's equal to a negative, once you get the absolute value by itself, or it's less than or equal to or less than a negative, then that makes a no solution, because there's no numbers in the world that can be negative distance from 0, right? Okay, so questions? Hopefully not. If so, just come and see me or send me an email, whatever, and we'll clear it up. Thanks. All right, here we go for our first superstar check. So write down, solve the equation, and our first superstar check is the absolute value of 5b, and then close the absolute value minus 7 equals 13. Remember that anytime you have absolute value, you have two solutions. So make sure by the time you're done, you have two answers. Most often, they will be two different answers. Right? So make sure you check your answers or click the choose the correct choice, and then we'll go on to the next one. All right, so our second superstar check is going to be just solve. Usually these say solve and graph, but because we're just doing a superstar check, I just want to make sure that you can solve it, and I'll worry about graphing tomorrow. So the absolute value of 1 minus 2x, absolute value, plus 1 is greater than 8. So again, remember that your first step has to be to get the absolute value by itself. So make sure you're doing that. If you don't do that in this problem, then you might have a little issue. All right, so work this out. Choose, hopefully one of the choices will be on the multiple choice, and then we'll go from there. All right, guys, have a great night, and I'll see you tomorrow. Remember that you rock, right? You are a winner.